Hello and welcome to another Lawrence Academy screencast. Today we're going to be talking about functions. More specifically, we're going to define functions and give you some examples. So let's start with the mathematical definition of function. So a function is a relation where every input has exactly one output. And to put that in, more clear terms, this means that for every x, there is exactly one y. So in this situation, x is the input, y is the output. So let's take a look at a function in action. So here I've made the function machine. So basically we can put in a single input to the function, and this function is x plus 3. Let's choose 2. So if I put 2 into the function machine, what comes out? Well, 2 plus 3 is 5. All right, if I put in, say, 7, if 7 goes into the machine, a 10 would come out. 7 plus 3 is 10. All right, so notice no matter what value I plug in there, there will only ever be one output. I can't plug in a 2 and get 5 and, 100. Right? I only will end up with one output. So oftentimes when we're looking at functions, we'll see them as equations. We'll see lists or sets of points, or we will see table representations. So let's take a look at some lists and tables. So here are a couple examples of possible functions or possible non-functions. So here we have 2 lists or sets of points and 2 tables down below. So let's take a look at the first list or set of points. So here we have 2, 11, 3, 7, and 4, 1. So notice that for each input, I'm only going to get one output. 3 to 7, and I have 4 to 1. All right, so this is actually a function. So let's take a look at the other list of points. So right off the bat here, we notice these first 2 sets of points. We have 3, 5, and 3, 7. So in this case, we have 3 going to 5, and 3 is also going to 7. So by definition of a function, this right here disqualifies this set of points from being a function. So this is not a function. Let's look at the tables. So it's going to be similar with the tables in that we're going to look for one output each. And the first one is a little bit tricky, so be ready. So we're looking at the table in red, and we have 2, 3, 5, 3, and 7, 11. So some of you guys right here are going to say, oh, there are 2 3s, so this can't be a function. But notice if we go back to what we did up here, we can go 2 goes to 3. That's a terrible 3, but we'll go with it. 5 goes to 3, and 7 goes to 11. All right, so in this case, each input that we have gives us exactly one output. All right, the definition of function doesn't say anything about having, unique outputs. So just because 2 goes to 3 doesn't mean 5 can't go to 3. And we're going to learn a couple other methods later on about how to determine what a function is or not. But the definition, for every input, there's exactly one output, and this holds true. So this one right here is a function. Now let's take a look at the one in green. Now, we see that 2 goes to 5, 3 goes to 3, 3 goes to 4, and 5 goes to 11. So now, right, these 2 points right here, similar to the second list, we have 3 going to 3, which is fine. But if 3 is going to 3, 3 can't go to 4 and have it be a function. So this one is not a function. And I'm just going to write NF. All right, so we've done some practice problems, and as is customary, I have some for you to try on your own. So take a look at these. There are three different problems, two lists and a table, and your goal is to determine, is this a function? All right, so go by what we know about the definition of function and tell me, is this a function? Best of luck to you. Thanks for watching. Have a good night. And there's your smiley face. Great job, guys.